Hello everyone, hello Sky Protocol community. So this is Gauthier once again. Today I am pursuing this series of developer interviews so that you guys can understand how our code works. So today I am with Manuel Simoni. For privacy reasons, like many developers, he wants to keep his face off the screen, and that's completely okay, but you will hear his voice and you will hear him comment his code. Hi Manuel, how are you?
Hi there, fine, thanks.
All right. So the stage is yours. You can share your part of the code now and explain that to us. And afterwards, I'll ask you a few other questions about what you understand from Skype Protocol. The stage is yours.
Yeah, so the Sky protocol addresses the problem that blockchains just don't have a lot of bandwidth. And the reason for that is that you have tons of computers that perform the same computations, and so you want to make sure that everyone can run a node on their own computer. And the problem of that is you just can't store a lot of data in the blockchain, and that's one thing we address. And you do that via Merkleization. So you take all of your data, which is a complete tree with many topics, and you can think of it like a file system tree. And then we store only the root node of that, which is a very small datum through Merkleization, which is also called content addressing. And then we just need to store that small root datum in the blockchain. And so we gain a lot of bandwidth that way.
Okay, wonderful. And so, which part of Skype Protocol are you working on at the moment?
I'm working on the contract side, which is written in Plutus, which is a language for the Cardano blockchain. And so the way it works, essentially, the our data availability layer is essentially rooted in a non-fungible token on the blockchain. So that's pretty funny, actually. So you can't just use NFTs for creating JPEGs. You can also use it to store a data availability layer. So essentially, the NFT gives us a unique token on the blockchain, so everyone can find it and can look at the root state of our Merkle tree.
Mm-hmm.
And so the contract there, which is also called a bridge contract, you can use that to update the root state. It's guarded by a multi-signature. So there is a committee that can decide on state changes.
Mm-hmm.
Right now, we use a very simple form of multi-signature that we're going to do something more advanced there in the future. But anyway, so this bridge contract stores the root of the Merkle tree, and other contracts can then depend on that root. So for example, you might have someone might create a bounty and say, okay, if you can prove that you've stored a particular datum somewhere in the Merkle tree in our data availability layer, then you can claim 50 ADA I've stored at a particular contract. So here we have those interplay between a bridge contract and a client contract, and that's what I'm working on.
All right, wonderful. And can you the Merkle tree is something that now our community is familiar with,
Mhm.
but can you vulgarize it very simply so that things get in the brain of the people who listen to us and who want to learn
Yeah,
more?
yeah. So the idea of Merkleization and Merkle trees is that from every datum you compute a code which is also called a hash, and that is unique for each datum. So if you have a file that contains text hello world, then you get a unique hash, and if you have a file that says goodbye world, then you get a different unique hash. And that hash is always the same size. And then you can combine multiple files into trees, and then at each level of the tree, you again get compute a hash. And finally, you come to the root, and then so you can describe an arbitrary size data tree as a single code, as a single hash. And this is what gives us scalability. So we only need to store the single small datum inside the NFT on the blockchain, and the single small datum can represent arbitrary large data trees.
Okay, and so basically that allows us to extrapolate and go back to the original data, which is much bigger, from just
Mhm.
a simple piece of data that can be stored on Cardano itself. So that's how we scale.
Yep.
Okay, and I'm going to ask the question. Of course, you already told me the answer, but this is for our listeners. Um, Basically, does that mean that we can basically retrieve the data from the outside, or is the algorithm secured so that only the person who accesses the origin of the tree can access the leaves of the tree, so the more complex data that is stored?
Yeah, so the root hash, which is stored on the blockchain, essentially verifies the complete data tree. So this guarantees the integrity of the data. Um, yeah,
All right. And so another question: where is the data stored then? If it's not on the main blockchain, the other data on the Merkle tree, where is it stored?
yeah. So this is in our own data availability layer for the testnet. This will be a simple centralized service, and later we will um, scale that out to a decentralized service with its own consensus. But in the testnet, it will just be like a simulation essentially. So this doesn't matter really for programmers because the API will already be by and large how it will be in the end. But initially, so you can develop apps against it,
All right.
and later on we will scale out to a decentralized system.
Yeah, and then this is where I come in with all the tokens of the Sky Protocol tokens that are stored to organize a DAO, so that basically we have a DAO where everyone can vote and the community can basically organize the whole thing. All right, and so last thing, can you please vulgarize a committee, and then I think our listeners will have already a few more notions.
Mhm. Yeah, committee is very simple. You have an organization and you decide via some governance procedure like who can make changes to the state on the data availability network. And so you might also have delegation there. So one committee might delegate some decisions about some parts of the data storage tree to another committee and at an infinitum. So you have a federated system of governance there.
All righty, that's wonderful. Great. Now, do you want to show us your code?
Oh, sure.
So please share a screen. And of course, for many people, this looks like code, and for many other people, this looks like hieroglyphs. So we need some vulgarization here.
One moment. Okay, can you see it? Can you see my screen?
Yes, we can. I'm just going to lower myself because the screen is more important than the faces. All right, we see that.
So here you have the Sky Bridge contract. That's our current for the testnet. This is essentially the core contract that validates updates to our NFT. You can find that in Sky Protocol contract source Sky Bridge contract. We have a couple of not so important definitions here. Here is our multi-signature definition. So that's right now we're just using a list of single signatures. Later on we'll use a more clever scheme there, but for the testnet this works. And here we have the NFT, which stores the single root hash of our tree.
Mhm.
And here we have the initialization parameters for the contract. So it's the only initialization it requires is the currency symbol for the NFT, which is like the unique hash of the NFT, minting policy. And here we have the data you send to the contract to update the bridge. So um, I'm not going to go into the detailed hash construction here, but essentially to update the bridge, you give it a new root hash and then you give it a signature for that and the old top hash and the old committee. And together with that, we can verify that the update is valid.
Okay,
Here we have a
so
bunch.
this is to make sure that nobody is basically
Only the allowed people, only
Yeah.
the decided by the committee can update the NFT. Yeah.
So that means you're not with this. You avoid the risk of having people sending many irrelevant operations or
Yeah. Yeah.
fake spending of tokens and so on. Okay.
Yeah. Then we have a bunch of utilities like for finding the NFT and stuff like that. And finally, we have the bridge validator itself. So this is the script that runs essentially inside the NFT, and this is pretty straightforward. So we just we have the core function. So we just say, okay, the multi-signature is valid, and the hash construction matches. So that's like the core validation, and then we have some administrative checks so that the NFT is again included in the transaction output, and the NFT has been updated with the new top hash, and that's the very simple bridge contract validation. So that's like the core contract, and we can also look at a client contract that makes use of the. So that here we have a bounty contract, which is one example of a client contract that makes use of that. So that's still the old simplified Merkle proof. So here you have the initialization. So you say, okay, so this is for creating a bounty. So you will upload this contract, you will log some funds at it, and then you configure it with these initialization parameters. You say, okay, someone should store a message with this particular hash inside the data tree under a particular topic ID, which is like one segment of the data tree. And we also pre-configure the claimant. This prevents some attacks. And here we also give it the NFT so that it can find the root hash. And then to claim a bounty, you supply essentially Merkle proofs that the data is in the topic and that the topic is in the tree. And then once you do that, you can unlock the funds that are locked at that contract address. And here we have the validation for such a contract, and you simply perform the Merkle checks, the Merkle tree validation checks, and you check that the top hash matches what's stored in the NFT, and then you know, okay, I can pay out the funds. That's one example of using Sky Protocol.
Wonderful. All right. Thank you so much. Is there anything else from the code that you want to show us this week?
Nope. I think those are the most important parts. So bridge contract controls the NFT, and client contracts like this bounty contract can then access the data in the NFT and control the release of funds. So I think that's the core idea.
Thank you so much, Manuel. I think these code reviews are great. We also have one with Yaroslav to release, and from time to time, it's interesting to have the point of view of our developers instead of the point of view of the of only the lead architect or the CEO. So thanks so much for playing that game. Everyone, Sky Protocol community, this was a little attempt of vulgarization of what we do. Tell us if you want to see more about that in the comments section, and follow us on Discord, on our Telegram, and on X, and see you later. Thanks, Manuel.
Okay, thanks. Bye. Bye, everyone.